All right, so this one is a limiting reactant problem. This says methanol is the simplest alcohol. It tells you in the problem that it is manufactured by combining gaseous carbon monoxide and hydrogen. So we don't have a reaction here. We need to actually write a reaction. So we're going to say H2, that's hydrogen. Remember that hydrogen is a diatomic molecule, plus carbon monoxide, which is CO, yields methanol, which they give you the formula CH3OH. So in order to balance this, we notice we have 4 H's over here and a C and an O. So we just need to put a 2 here and then everything's balanced. So it's not a difficult reaction to write or balance, but we need to still have it so that we can do our stoichiometry. The first question here is calculate the theoretical yield of methanol. So in order to calculate the theoretical yield, we have to find out what the limiting reactant is because we have 2 reactants that we have mass for here. So that is a limiting reactant problem every time. They're in kilograms, which is kind of a pain. So let's just convert them to grams. 68.5 kilograms, and there's 1,000 grams in a kilogram. So we're going to start with 68,500 grams. You can do that with dimensional analysis, but it's just easier for me to just kind of write it down, of carbon monoxide. We're going to start with that. We're going to do 1 mole of carbon monoxide is equal to 28.02 grams of carbon monoxide. Now we use the coefficients from our balanced equation to get into, we're trying to get to methanol here, the theoretical yield of methanol. So we say there is 1 mole of carbon monoxide to 1 mole of methanol. Okay, so now we need to get to grams. Theoretical yield is always in grams. And that is 32.04 grams of methanol to 1 mole of methanol. So when I calculate this out, I get 7.83 times 10 to the 4th grams of methanol. So I don't yet know if that's right. I don't yet know if that's my limiting reactant. I need to do another one. So I have 8.60 kilograms of H2. So I'm going to do 8,600 grams of H2. And 1 mole of H2 weighs 2.016 grams. Now in my balanced reaction here, I have 2 moles of H2 to 1 mole of methanol. And I finish it the same way, 32.04 grams of methanol to 1 mole. And I end up with 6.83 times 10 to the 4th grams of methanol. Okay, so I have 2 answers. It's important to write an or here because we don't know which one's right, but it's important to remember that it can't be both. So we've got to pick one. We're obviously going to run out of hydrogen before we get to this whole 7.83 times 10 to the 4th grams. So we're going to be able to make this much, the 6.83 times 10 to the 4th grams, and then run out of hydrogen and still have more carbon monoxide to be able to make more methanol. So unless we get more hydrogen, we can't ever get to this amount. So this is not the right answer. The theoretical yield of methanol will become this one. Theoretical yield. Okay, so we've answered part A. Now, part B says if 3.57 times 10 to the 4th grams of methanol is actually produced, then what is the percent yield of methanol? So that's easy enough. We take our experimental or our actual yield. So we take 3.57 times 10 to the 4th grams over our theoretical yield, which is 6.83 times 10 to the 4th grams. We multiply by 100 to get our percent, and we end up with 52.2% yield. Okay, so now we've answered part B. Part C is a little more involved. what mass of the excess reactant remains? So we know already that H2 is our limiting reactant, okay? And we label it as such. So our excess reactant is going to be carbon monoxide. But we don't yet know how much carbon monoxide has been used in this reaction. We know how much we started with, but we don't know how much has been used. So we have to start over with our limiting reactant and do the calculations. So we start off again with our 8,600 grams of H2. We start the same way. 1 mole of H2 is 2.016 grams of H2. Now we're going into carbon monoxide, remember. So we have 1 mole of carbon monoxide to 2 moles of H2. We're going to use our molar mass now. So we have 1 mole of carbon monoxide to 28.02 grams of carbon monoxide. And we end up with 59765 grams of carbon monoxide, which is 59.8 kilograms of carbon monoxide. We started with 3 sig figs here and 3 sig figs here, so I'm going to end up with 3 sig figs here, just like we ended up with 3 sig figs there. And the reason I converted it back to kilograms is because my starting amount is in kilograms, and it's just easier for me to subtract that. So I'm going to take my 68.5 kilograms of CO that we started with, and we're going to subtract 59.8 kilograms of carbon monoxide that we used. And we end up with 8.7 kilograms of carbon monoxide remain. Okay, so that is our answer to letter C there.